As promised, we're back and we're concluding our roadmap. And I copied this piece here because it was responsible for the rest of the molecules. And we're taking an ethyl group, we're keeping the ethyl group until here, and then we're making a bromine on the benzylic position of the ethyl group. Interesting. Let's not get too far ahead of ourselves, though. What kind of a group is an ethyl? Because our next group is going to be a nitro group. HNO3, sulfuric acid. Ethyl is a ortho-para-director, so major W, sorry, X is major, will be the ethyl benzene with the nitro in the para position. And W, let's leave room for X to wander all the way over to S. And W will be the nitro group in the ortho position. And here we go. Dealing with X. Let's go X all the way to S. So what's happening to X when we do potassium dichromate sulfuric acid in water and heat? This will generate chromic acid. And with the heat, a benzylic carbon will become a carboxylic acid. So V will be looking like this. Nitro group will be unaffected by those proceedings. Yep, you lose the carbon off the ethyl, the second carbon, and the first carbon, the benzylic carbon, becomes a carboxylic acid. So that is V. When you treat both nitro groups with lithium aluminum hydride and carboxylic acids with lithium aluminum hydride, you get reduction of each. And we need to know that a nitro group becomes an NH2 and a carboxylic acid becomes a primary alcohol. Yeah, the stuff we learned before never goes away, does it? Primary alcohol and an NH2. And that's molecule U. What's going to go on when we react U with sodium nitrite, HCl, and 0 degrees? You get the N triple bonded to N. Where's the second N come from? It comes from here. And that's a diazonium ion at 0 degrees. And I forgot to add the temperature restriction here. This will happen when you warm it up to room temperature. Put that in after the fact. And that will convert the diazonium that you just made into a C triple bond to N. So that would be T. T is right here. You got your benzene. Got your OH. And you have your C triple bond to N. Nitrile. Benzonitrile, if you want to be specific. And what's S look like? Oh, look at that. We'll even put it right by the S. I know you can't do that on the test. Not fair. You would write S on your answer page, which is not a big deal, and then write down what you think S should look like. Step 1 is going to reduce your C triple bond to N to a primary amine. So H2PT will make this a CH2 and this an NH2. No more pi. And that's a primary amine which reacts with ketones to make, what was it again? Primary amines, ketones. We're back to test 1 now. Dean-Stark trap. I know it's some kind of condensation reaction. And scratch my head. I'm going to get an imine. It's an imine. And imines are C double bond to N. Water's lost because it's a condensation process. So you get CH2N, double bond, to the carbon that used to be the carbonyl carbon of acetone. There it is. And now my T is in the way. You got that. And this was molecule T right here. And save. So yeah, good stuff. Using the old stuff and the new stuff together, huh? Now we have to take our W right here and reagents E. And it looks like we have an NO2 ortho to an NH2. Here we have an NH2 ortho to a C. What did I say this was? It's an ethyl to an ethyl. It looks like the ethyl stays the same. The NO2 is an NH2. I believe this is maybe the fourth time on the roadmap we've reduced NO2 to NH2. Yep, we don't put an arrow. We'll just put the reagents E that do this. H2 and nickel is a very popular one. Ethyl group will not be touched by that. And then F. I'm really emphasizing these things happen over and over. The answer for F is right here in steps 1 and 2 up here. Just copy them. You're converting an NH2 to a C triple bond N. NH2 to a C triple bond N. U going to T. And I need the reagents U going to T here. And that's going to be called F. And F is NaNO2. Get practice, draw these out. HCl, excess, aqueous, keep it cool. That's step 1. There are no shorter ways to draw this out. I need every piece of information there. You can't cut any of them out to save time. KCN, CuCN, and room temperature. Yeah, the one I forgot I want. It's the room temperature that allows the N triple N to be replaced by a cyanide. And that's your reagents F. And then some reagents G. Well, I think that's on this page too. We're taking a C triple bond N here to CH2NH2 here. I verbalized it here. The C triple N here became CH2NH2 before it underwent condensation with acetone. Well, how did we do that? Well, we reacted H2 and PT to get the C triple N to be a CH2NH2. H2PT. I would take H2 nickel if you want. Let's separate these things out here so we know E was just what's in there. And then G. H2 nickel, H2 platinum, H2 some transition metal. I would take sodium borohydride followed by HCl. That worked with the nitriles. That's a good G as well. And what I'm trying to tell you there with the square parentheses there, this is an intermediate. You probably wouldn't see any of this. It would react to make a bicyclic molecule. Well, we've got one ring already. Where's the second ring come from? Second ring comes from a nucleophile in a position to make a reasonably sized ring. If it attacks this position here, how big will this ring be? Nitrogen will be in the ring, and the other end of the ring will be the carbon with the leaving group. 1, 2, 3, 4, 5. That's a very nice ring size. So molecule O will be right here. And it'll be the benzene with a random electron out there. Don't like that. Double, double, double. And we go CH2, goes to an N. The N will have one H when we're finished. It did a backside attack on a carbon that was bonded to the ortho position. The carbon had a methyl as well. Now, you originally would have got this. I'll draw it and erase it. You would have got that originally. And then that's an ammonium ion, gets neutralized under. I would accept this as your product. I would accept that, and I would accept this as well. Because you don't have to neutralize an ammonium ion. It's not a strong acid. So I'll take that. And I'll also take this. So I want to make sure that's clear. Okay, my pen's off. Take that. Or I'll take this. There you go. And I believe that's the whole roadmap. And that's correct.
Professor?
Yes.
How did we get the bromine in the ethyl group?
Oh, that's a point which I did not address. That should be a 3-point G. Where's G? Where's G? That, oh, yeah, it's 2 points, and I only got 1 point worth of work on there, huh? You caught me. Good job, by the way. Yeah, step 1 was to reduce it to CH2NH2. And step 2 is to put a bromine on the benzylic position. You could say bromine and heat, Br2 and heat. I'd give you full credit probably. A better set of conditions, though, for benzylic and allylic brominations is to use N-bromosuccinimide and heat. And that would put the bromine on there. And just a reminder, N-bromosuccinimide looks like this. Oh my such. It's a diacid derivative of the imide variety. 4 carbons, 1, 2, 3, 4. That's oh my such good. 4. And heat, there's NBS. And that would put the leaving group there, which would allow us to make the bicyclic molecule. And thank you, that's a good interruption. And we're not going to quit because we still have time, and we're going to introduce our final chapter of new functional groups before we go strictly into biochem. Biochem for us is just applied organic chemistry, all the stuff we've learned from 2 courses, and we're just going to relate it to biological molecules. So we're almost ready for that. But to get there, we have to do our final functional group, a very important one called amines. Chapter 23 is amines. I have to confess, I stole this joke from the internet. Former student sent it to me one day. Here is a molecule that's got an amine and a carboxylic acid. It's called phenylalanine, one of the 20 amino acids. And it's copying some attitude here. It's asking some other molecule to give its lunch. And then somebody's asking, why do you have to be such an amino acid? Oh, it's lame, I know. Amine acid. Okay. All right. What makes something an amine? Well, it's got a nitrogen attached to carbon. Is that going to cover it? The carbon cannot be a carbonyl carbon. In fact, if you can't have one carbonyl attached to nitrogen, we know what that's called. That's called an amide. If you have 2 carbonyls attached to nitrogen, what do you call that? You call it an imide. No carbonyls, just a carbon or 2 carbons or 3 carbons. We call them amines. Primary amines, secondary amines, tertiary amines. Unlike oxygen functional groups, Nitrogen functional groups are more straightforward. To get the degree sign, you just count the bonds to carbon off the nitrogen. 1, 2 bonds to carbon, secondary, 3 bonds to carbon, tertiary. Name, and we have these aromatic amines, means the nitrogen is in a ring. An aryl amine means the nitrogen's attached to a ring. Our most common molecules being aniline and naphthylamine. This is the naphthyl group. Interesting thing about naphthalene that I don't believe I addressed before, or if I did, it was just in the book. If you want to put groups on naphthalene, there's basically only 2 positions to put groups on. There's the carbon that's 1 away from the bridgehead, which is called alpha, and the carbon that's 2 away from the bridgehead, which is called beta. 1 away is called alpha, 2 away is called beta, 1 away is alpha, 2 away is beta. So maybe that explains the name alpha naphthylamine. The alpha position's 1 away from the bridgehead. You can't put groups on the bridgehead. That'd be an octet violation, so they don't even bother giving it a letter. 1 away is alpha. Please learn that. And what about the numbering system of the aromatic amines? Why do we have a nitrogen as position number 1? Because the hetero atom is always position number 1. So over here it's not written, but that's the 1 position. So let's do lots of practice problems after we look at the nomenclature of things here. Pyrimidine, we are getting you ready for biochemistry. The 2 ring systems found in DNA and RNA and things like ATP, GTP, CTP. The 2 ring systems involved are pyrimidines and purines. Pyrimidine is the monocyclic that's also found in purine. If you look at it, there's a pyrimidine in purine, but there's this extra imidazole over here. So we have to learn what an imidazole is. Imidazole is 3-azapyrrole. If this is pyrrole and you're putting a nitrogen in the place of a carbon, we say that by saying aza. And 3-azapyrrole would be a name that most chemists would understand you, but they say, oh, you mean imidazole. So we should need to know these things. Students need to keep it straight. The bigger one in the DNA is called the purine with a smaller name. That's how I remember it. The bigger ring system has the smaller name, and the smaller ring system has the bigger name. Just remember that. Shows up in things like the PCAT a lot. All right, what else do we have? We have normal amines. Why is this called 2-pentanamine? I think you understand it's got a 5-carbon chain, and the amine is attached to carbon 2. So you can use what we've learned about general nomenclature before and say an alternative name that's just as good. Pentanatuamine. And you could also recognize that that is a sec-pentyl group on the nitrogen. And that would be sec-pentyl group attached to an amine. Common naming is easy. Name the R group attached to the amine and just throw the word amine at the end. That's a sec-pentyl. N-methylethanamine is the UPAC name. The longest chain of these 2 is the 2-carbon ethyl. So you want to call it an amine, it's an ethanamine. That also has another group on the nitrogen, and we've already learned that. You say groups on nitrogen, you throw an N in front, and you name the group, and then the chain. Common naming is a little like ethers, ethyl methyl amine, alphabetical listing of the groups, and then the word amine. Pretty straightforward, huh? This one, which of the three groups has the longest chain? The the prop. I just fell into a common trap, the P trap. Prop is 3, pent is 5. This is not 5, it's 3. Propanamine with ethyl and methyl on nitrogen, and ethyl right here and methyl right there. Or just list the three groups alphabetically first: ethyl, methyl, propylamine. A little awkward, but it works just fine. Let's do a few practice problems here before we move on. Let's draw our N isopropyl. Let's give the pentyl some due. Isopentyl, since we talked about it behind its back. N isopentyl for nonamine. I think we could do that. It's not that bad. I can sense a problem set starting maybe with one of those types of molecules. So where's your starting position? You're going to start with a non-Neil. 2, 4, 6, 8, 9. 2, 4, 6, 8, 9. And on the fourth position, we have nitrogen. Once again, I'm not going to put my stereo center on until I'm finished, figured out what's going on. On the nitrogen, we also have another group. It's an isopentyl. So we draw 4 in a row for butyl, and then a V on the end. And guys, don't leave it like this. I see students leave it like this, even in Orgo 2, after they've seen this for a long time. You can't leave hydrogens off nitrogen. You can't. Stick figure rules say the only hydrogens that can be omitted are the ones on carbon. So please put the H on the nitrogen. There. And you have partial credit. We have a stereo center. And the 4 things on my stereo center are a hydrogen group, a propyl group, a pentyl group, and a nitrogen. 1 for N, 1 for CH2 that keeps going CH2s, another 3 for CH2 that ends with CH3. This is old school for you guys now. I should just give, 1, 2, 3, 4. Oh, 1 and 2 and 3 are already clockwise. The name indicates they should be clockwise. And that just means put the H on a dash. And one of the adjacent bonds on a wedge. And you're done. Let's do a bicyclo. Let's draw. Yeah. N-benzyl bicyclo. And we're going to put 4 aza. Oh. N-benzyl bicyclo. 7, 4, 3. Hexadec. Ane. And what else we got here? 4, I've got that. These benzyl. All right, we'll put 1R and 9R. That'd be a good one for us. What does the aza mean again? On position 4 of my molecule, if I drew it without aza in the name, there'd be a carbon. Aza means replace that carbon with a nitrogen. That's what aza means. So traditional bicyclo, you draw your dots. connect with the right number of carbons between the dots. 1, 2, 3, 4, 5, 6, 7. And 4. 1, 2, 3, 4. And then 3. 1, 2, 3. And where's 4 if you decide to make this 1? 1, 2, 3, 4. It's right there. So I'm going to just erase a little bit right here. 1, 2, 3, 4. So I'm going to throw a nitrogen in there. And the nitrogen has this. And guys, it's a nomenclature question. You're not allowed to write F. And remember, benzol is a phenyl with an extra carbon that's attached to something. That's our benzol. It's on the aza nitrogen. And we have stereocenters without groups. Oh, I wish we could do that more often. It means each stereocenter also has an H. And prioritizing. 1 and 9 is down here. 2 is here and 8's there. Biggest bridge, right? And in terms of 1, 2, 3, 4 for stereocenters, definitely a 4 for the H. And CH2 that hits a CH2 with an N is going to beat CH2 that hits a CH2 with a CH2 that hits a branch, which is going to beat CH2 that goes CH2, CH2 one more time, then a branch. And were we lucky? We're very lucky today. This is already R if I put the 4 on a dash, so let's do that. And wedge adjacent, maybe the 3. See how lucky we are on the bottom one. You got your 4. Got your 1 here. Yep. Why is that the 1? Oh, maybe it's not. 1, 2, 3. Yeah, it is. Let me make sure, though. CH2 once, twice, 3 times, then a branch C. CH2 once, twice, 3 times, then a C that's not branch, but it has an N. Oh, I made a mistake. I'll go slower. CH2 once, twice, 3 times. What's the heaviest thing on the third CH2? A C. CH2 once, twice, 3 times. Then a C. What's the heaviest thing on this C? An N. 1, 2, 3 times, then a C. 1, 2, 3 times, then a C. That's tied. So we're tied up to here. All the way up to there, tied. What's the heaviest thing on the C? N. What's the heaviest thing on the C? Another C. So that makes the C down here the number 1. Oh, I better have a pen going, though. And that makes that the 2. Stereocenters can sometimes be entertaining. And we weren't so lucky. That doesn't mean anything. Just put the 4 on a wedge. These are counterclockwise, the 1, 2, 3, and I need them to be clockwise, which means if 4 is on a wedge, that's going to give me my right answer. Adjacent dash goes all the way. And there we have it. And let's draw, sticking with the drawing parts, huh? How about naming? Yeah, name. And there you go. Ah, that's one of our rings that we're supposed to know about, called what? Azabenzene? Don't call it that. We've been calling it pyridine for months now. What's that group on my pyridine on, and what position is it on? Heteroatom in ring, number 1. 2, 3 to get the lowest number for the group. And yes, that's our old, or our new favorite group of the chapter or test. Nitropyridine. Okay, do we need more practice? Let's see. Let's draw one more. Draw Imidazole 2 carbaldehyde. Imidazole. What was imidazole again? And we have to learn these. If they're up there in this box, we need to know all of them. Imidazole is over here. So how do you remember imidazole? Well, we got to learn parole anyway. Parole it's aromatic. We learned it. It was in chapter 21. We said we had to use that lone pair as pi electrons, not as a lone pair, as pi electrons to get up to 6 to make it aromatic. Imidazole, you're using the same 2 here. Don't use the 2 that are here. I'm going to erase them in a second. Those are not needed for aromaticity. They give us the wrong number anyway. Plus, nitrogen's already pi bonded right here. You can't use more p electrons from the same atom. Anyway, my whole point is imidazole is parole with an extra nitrogen on the 3rd position of the ring. In position 2, which my molecule requires an aldehyde group on, is right there between the nitrogens. So how do we draw imidazole? Use your memory. We had to draw parole up here. You got your parole. And one of the corners is really a nitrogen. On position 2, carbaldehyde. That's a carbaldehyde. And I think that's a pretty good spot to stop, even though we're a little early. Early's not always a bad thing. All right. So we'll see you on Wednesday. We will be doing, I think the Lions part of chapter 23 will be finished as of Wednesday, and we will be pretty much done with test material after this week, giving us lots of review opportunity. And I will see you Wednesday.